There's something unusual moving through our solar system, an object traveling at incredible speed, too fast to be bound by the sun's gravity. Astronomers call it 3I Atlas, the third known interstellar object to ever pass through our cosmic neighborhood. It first appeared in early May 2025, when telescopes in Hawaii noticed a faint speck of light that didn't match any known asteroid. At first, researchers thought it was just another rock drifting through space. But when its velocity was measured, it became clear. This thing wasn't from around here. Everything that orbits the sun does so because of gravity. Planets, asteroids, and comets are trapped within its pull. But 3I Atlas is different. It's moving too fast, on a path that cuts through our solar system and keeps going. That means it came from deep interstellar space, passing through on a one-way journey. The object takes its name from the system that found it, ATLAS, the Asteroid Terrestrial Impact Last Alert System, a global network of telescopes built to track near-Earth objects. They scan the night sky, taking images every few seconds, looking for anything that moves. When ATLAS noticed this one, it didn't just move, it raced. Its trajectory told us everything. It wasn't looping around the sun like a normal comet. It was on a hyperbolic path, the unmistakable signature of something not bound to our star. That's when scientists realized this is the third visitor from another solar system we've ever seen. The first was Oumuamua, detected in 2017, a mysterious cigar-shaped rock that sparked endless debate. The second, 2I Borisov, discovered in 2019, was more like a traditional comet, leaving behind a bright tail. But 3I Atlas is something else entirely. It's much larger, possibly over 5 kilometers across, and it's faster, moving nearly 60 kilometers per second, twice the speed of most comets. But the strangest thing about 3I Atlas isn't its size or its speed. It's the direction it came from. Most comets enter from above or below the solar plane, tilted paths that make sense for incoming interstellar travelers. But Atlas came in sideways, almost perfectly aligned with the orbits of the planets. That's a rare coincidence. Out of all possible directions in space, this one came in at just 3 degrees off the ecliptic plane, the same flat disk where all the planets orbit. This alignment has scientists puzzled. Why would an interstellar object arrive at such a perfect angle? Some think it's just chance. Others suggest it might tell us something about where it came from. Perhaps a region of the galaxy where planetary systems form in a similar flat configuration. As Atlas approached the sun, astronomers noticed something else. Even while it was still far from the sun, beyond the orbit of Jupiter, the object began to glow. It was already ejecting gas and dust, forming a faint halo known as a coma. That shouldn't happen at such low temperatures. Typical comets from our solar system stay frozen until they get much closer to the sun, around 3 or 4 astronomical units away. But Atlas started to activate at over 5 AU, where it's still extremely cold. That told us something important. This object isn't made like our comets. Instead of being dominated by water ice, 3I Atlas is rich in carbon dioxide, dry ice that vaporizes at much lower temperatures. This explains why it began releasing gas so early. Its chemistry reflects a different kind of solar system, one formed under colder, harsher conditions than ours. When NASA and ESA aimed their best instruments at it, including the James Webb Space Telescope, they detected an unusually high ratio of carbon dioxide to water vapor, about 8:1. That's the inverse of what we usually find in local comets. Even stranger, Webb spectrometers revealed traces of metals like nickel, but no iron. Nickel and iron normally form together inside dying stars. then scatter across space when those stars explode. So when astronomers found nickel without iron, they knew something strange had happened to separate them. Later, as Atlas moved closer to the Sun, traces of iron finally appeared, meaning it was releasing new layers of material as it heated. It's as if the comet were slowly unwrapping, revealing a history written in ice and dust. By October, the object reached its perihelion, its closest point to the Sun, roughly 210 million kilometers away, just inside the orbit of Mars. At that distance, it wasn't close enough to burn brightly in our sky, but it was close enough to study. Unfortunately, our view from Earth was blocked by sunlight during the peak, but we had another vantage point, Mars. On October 3rd, 3I Atlas passed within 0.19 AU of the red planet. From the surface, NASA's Perseverance rover captured faint, long-exposure images of the glowing object. It wasn't much, just a small streak against the dark Martian sky. But it was proof that this interstellar traveler had passed right through our neighborhood. The ExoMars orbiter also photographed it from orbit, confirming the shape of its short, fan-like tail. At first, that tail pointed the wrong way, toward the Sun. Comet tails are usually pushed away by the solar wind, but this one seemed to form in reverse. Later, as Atlas drew nearer the Sun, the tail flipped, aligning as expected. Astronomers believe the early reversal happened because the solar wind was too weak at that distance to push against the heavy CO2 cloud. The behavior of this comet tells us something deeper about where it came from and what kind of environment shaped it. Based on its chemical signature and velocity, researchers believe Atlas originated in the thick disk of the Milky Way. That's an ancient region, filled with stars that formed over 7 billion years ago. If that's true, then this object could be almost twice as old as Earth itself, a frozen relic from a star system that existed long before ours. And somehow, after billions of years drifting between the stars, it found its way here, to us. As 3I Atlas passed its closest point to the Sun, scientists were ready. Dozens of observatories across the world turned their instruments toward it, from ground-based telescopes in Chile and Hawaii to orbiting platforms like Hubble and James Webb. Every major eye in space was watching. But what they saw wasn't what they expected. Normally, when a comet heats up, it erupts. It brightens dramatically, shedding tons of dust and gas, forming long tails visible for millions of kilometers. Yet 3I Atlas stayed unusually calm. Its coma, the glowing cloud surrounding it, didn't expand much. Instead of bursting with chaotic jets, it released material slowly, evenly, as if it were venting through controlled cracks. Some astronomers compared it to a frozen volcano, releasing gases through pressure vents rather than explosive outbursts. Then, something stranger happened. The object began to pulse, not in brightness, but in the distribution of its gases. Images from the European Southern Observatory showed a rhythmic expansion and contraction of the coma every few hours. It was like the comet was breathing. That caught the attention of researchers at NASA's Jet Propulsion Laboratory. They ran computer simulations and found the pattern could be explained by slow rotation, about once every 11 hours. This rotation caused sunlight to heat different sides in sequence, releasing waves of gas and dust. It wasn't alive, of course, but the rhythm gave it a strange, almost lifelike motion. As the weeks passed, 3I Atlas began to fade. It was heading back out of the solar system, gaining distance fast. But the data it left behind is transforming what we know about interstellar objects. Every previous visitor, from Oumuamua to Borisov, offered just a brief glimpse, but Atlas stayed visible for months. That gave astronomers a rare opportunity to study how such objects behave as they cross our solar system. Spectroscopic readings from NASA's Infrared Telescope facility revealed something surprising: the presence of ammonia mixed with the carbon dioxide. Ammonia is common in the outer regions of young star systems, but rare in older ones. This suggested Atlas formed not in a dying system, but in a newly born one, possibly around a star still surrounded by its original protoplanetary disk. That detail changed everything. It means Atlas could be carrying some of the raw materials for life, the same kind that helped form planets like Earth billions of years ago. If its ices contain amino acid precursors, molecules that form the building blocks of proteins, then this comet isn't just a visitor, it's a messenger. A frozen time capsule from another star, holding the chemistry of an alien world. NASA's Planetary Science Division confirmed that Webb's readings show organic-like signatures, faint but real. They're not proof of life, but proof that the ingredients for life might be universal. Meanwhile, astronomers back on Earth continued to track its movement. By late October, the comet had crossed Mars' orbit and was speeding toward the asteroid belt's outer edge. Its current speed over 52 kilometers per second. At that pace, it will leave the Sun's gravitational influence entirely within a few years. But here's the most haunting part. Once it leaves, it's gone forever. There's no way to catch it, no spacecraft fast enough to follow. It will continue drifting between the stars, carrying with it the evidence of another solar system we can only imagine. Still, not everyone is ready to let it go. Some scientists at the European Space Agency have proposed a daring idea: to launch a future interstellar interceptor, a spacecraft that could be parked in deep space waiting for the next visitor. Then, when another object like Atlas is detected, it could be redirected instantly to intercept it. That mission, called Comet Interceptor, is already under development. It's set to launch later this decade and could be in position by 2030. Its goal? To study the next interstellar object up close, something we missed the chance to do with Oumuamua, Borisov, and now Atlas. If successful, it would give humanity its first direct contact with matter from another star. Actual samples collected and analyzed, revealing how other solar systems form and evolve. But until then, 3I Atlas remains a mystery. We only have its light, its spectrum, and the trail of dust it left behind. From that, we must piece together its story, where it came from, and what secrets it carries. One possibility is that it was ejected from the outer edge of a star system much like our own, perhaps after a giant planet shifted its orbit, flinging debris into interstellar space. Or maybe it was torn loose during a stellar encounter, when two stars passed too close to each other, sending their planets and comets scattering. Whatever the case, Atlas has been traveling for an unimaginable amount of time, billions of years through silent darkness, untouched, unseen until now. Its surface has been shaped by cosmic rays and frozen winds. Its core, still pristine, sealed away, holds the chemistry of its birthplace. When we study it, we're not just learning about one comet, we're learning about the entire galaxy's history, how materials move between stars, how planets form, and maybe even how life begins. In the end, 3I Atlas reminds us how small and connected we really are, that across the emptiness of interstellar space, a fragment from a forgotten world can drift for eons and still find its way here.
As 3I Atlas moves farther from the Sun, the light reflecting off its surface grows fainter, but the data keeps coming in. Every night, telescopes around the world combine their readings to build a clearer picture of what this interstellar traveler really is. The first question scientists asked was simple: where did it come from? When NASA's Minor Planet Center analyzed its incoming trajectory, they noticed something strange. The path didn't point back to any known star system near our solar neighborhood. Instead, its origin seemed to trace back toward the constellation Lyra, near the direction of the bright star Vega. But Vega itself is too young to have produced such an ancient object. So researchers at Harvard Center for Astrophysics ran more simulations, tracing Atlas's route backward through galactic space. Their models suggested the object could have been traveling for more than 7 million years. That means it left its home system long before humans even existed. Even more interesting, its speed relative to the galactic frame was unusually low. That hints at something profound. 3I Atlas wasn't flung away violently, like debris from an exploding planet. It might have simply drifted free after a gravitational interaction, a slow ejection, perhaps caused by migrating giant planets. If that's true, then Atlas could be just one of countless fragments cast adrift by newborn solar systems across the galaxy, each one carrying chemical fingerprints of its parent star. In other words, the Milky Way could be filled with interstellar comets wandering in silence between the stars. The James Webb Space Telescope provided more answers. Its deep infrared observations revealed a curious mixture of carbon compounds and silicates on the comet's surface. These are the same materials found in early protoplanetary disks, but the ratios were off. Atlas's silicates were unusually pure, almost glass-like, as if they had never been exposed to much radiation. That purity suggests it formed in a cold, dense region shielded from its star's light, possibly far beyond the snowline, where sunlight cannot reach. That matches recent NASA data hinting that Atlas could have originated from a binary star system. Two suns orbiting each other would create powerful gravitational forces capable of ejecting material cleanly into space. If that's true, then somewhere out there, another sun, and maybe a family of planets once shared a sky with this very object, and now it's crossing ours. As the weeks go by, Atlas continues to drift outward past the orbit of Jupiter. Its coma fades, its tail dissolves into the background of stars. But long after it's invisible to our eyes, the data will continue to speak. One unexpected discovery came from the Solar and Heliospheric Observatory, which detected faint ion traces left in the solar wind. Tiny particles, charged and swept away, now floating through the inner solar system. These particles, though microscopic, are now part of our cosmic environment, interstellar dust blending with our own. Think about that for a moment. Right now, particles from a completely different solar system are mixing with ours, carried by the solar wind, drifting toward Earth's magnetic field. Some of them may even fall through our atmosphere, tiny remnants of an alien world, becoming part of our planet's dust. To the average person, it's just another comet. But to scientists, Atlas is a messenger of galactic history, a reminder that solar systems are not isolated islands, but part of a vast cosmic current. Back at NASA's Goddard Space Flight Center, researchers began comparing Atlas's composition to models of our early solar system. The match wasn't perfect, but it was close enough to suggest something amazing. The basic building blocks that formed our planets might be common everywhere. Carbon, oxygen, nitrogen, silicon. The same ingredients appear in distant comets like Atlas and in the dust clouds where stars are born. That universality gives hope to one of humanity's oldest questions. If life could emerge here, could it also emerge elsewhere? For astrobiologists, Atlas represents more than a passing rock. It's proof that the galaxy is chemically alive, full of shared ingredients, scattered and recycled over billions of years. Every comet that drifts between the stars carries that story forward, connecting one system to another. And yet, despite all the scientific fascination, there's still something deeply emotional about watching it go. The idea that a piece of another world has passed through our sky, unseen by most, and is now leaving us behind. In a way, Atlas is like a cosmic traveler, stopping by for a brief visit before continuing on a journey that never ends. And while we can't follow it, we can listen to the echoes it leaves in the data, in the light it reflected, and in the questions it inspires.
As 3I Atlas drifts beyond Jupiter's orbit, it begins to fade from view. The once bright coma has nearly vanished, and the sunlight no longer reaches deep enough to warm its frozen core. To most telescopes, it's now just a faint glimmer in the dark, a pixel among countless stars. But even as it disappears, scientists are still uncovering its secrets. Data from the James Webb Space Telescope continues to arrive, providing the clearest chemical fingerprint yet of an interstellar object. Webb's instruments detected complex hydrocarbons, long chains of carbon and hydrogen, similar to those found in the Murchison meteorite on Earth. These compounds, known as polycyclic aromatic hydrocarbons, are among the simplest organic molecules that can form in space. They're not alive, but they're precursors, raw material for biology. The fact that Atlas carries them suggests that the chemistry of life might not be unique to our solar system at all. When this data was presented at NASA's 2025 Planetary Science Conference, it made headlines. Because for the first time, scientists could compare organic chemistry between two different solar systems, ours and another, and the resemblance was unmistakable. It's not proof of alien life, but it's one step closer to understanding that life, as we know it, could emerge anywhere conditions allow. The same atoms that make up our oceans, our atmosphere, even our DNA, might be scattered across the galaxy, waiting to come together again. Meanwhile, Atlas continues its silent journey. By the end of 2025, it will have passed the orbit of Jupiter, heading toward the outer solar system at nearly 60 kilometers per second. In a few years, it will reach the edge of the heliosphere, the boundary where the sun's influence ends and interstellar space begins. Beyond that, it will drift into the galactic void. No more sunlight, no more warmth, just eternal night. It will travel for millions of years, possibly passing near other stars, perhaps even brushing through another planetary system someday. To those future observers, wherever they are, 3i Atlas will look like it looked to us. A faint, fast-moving comet from the stars. A visitor from elsewhere, bearing stories from a place they'll never see. Here on Earth, missions are already being planned to prepare for the next one. The ESA Comet Interceptor mission, scheduled to launch later this decade, will sit in a waiting orbit near the Lagrange point L2, ready to spring into action when the next interstellar object is detected. Its goal is simple but bold: intercept a visitor like Atlas, fly alongside it, and study it up close before it vanishes forever. If successful, it would be the first time humanity ever touches something from another star system. A glimpse into the unknown captured by machines built on our small blue planet. NASA, too, is developing proposals for an interstellar probe, a spacecraft designed to leave the solar system entirely and observe objects like Atlas from beyond the sun's influence. Together, these missions mark a turning point, a new era in space exploration that stretches beyond our home star. But for now, all we can do is watch as Atlas fades. A distant traveler, shrinking into the blackness, carrying with it secrets we've only begun to understand. It's humbling to realize that this object, born around another sun, perhaps in a system long dead, has come so far, only to be seen by us for a brief moment. Then, like a whisper, it continues on its way. Astronomers estimate that interstellar visitors like Atlas may pass through our solar system every few years. Most are too small or too dim to detect. But each one reminds us that our solar system isn't isolated. It's part of a living, moving galaxy. We share space with countless other worlds, each one leaving traces of its existence in the form of dust, gas, or ice. And every once in a while, one of them finds its way here, close enough for us to notice, study, and wonder. In the grand timeline of the universe, our encounter with 3i Atlas is just a fleeting moment. But for humanity, it's a glimpse into the vast cosmic ocean we belong to, an invitation to look outward, to imagine what other stories are hidden among the stars. Because if a single fragment of another world can reach us, then maybe, someday, we can reach back.